Okay, we're going to learn about something called a power series, and the definition of a power series is in this box in the middle of your page. And if you look at the series, it looks very similar to a Taylor and Maclaurin. So this is a power series centered at 0 because you have x minus 0 raised to a power. This is a power series centered at c because you have that x minus c in every term. Notice there's coefficients in the front. Notice the x's are raised to an exponent. So very similar to a Taylor and a Maclaurin. So basically a Taylor and a Maclaurin series are special types of a power series. So these two power series down here, this is centered at 0, this is centered at x equals 1, and we are interested in the radius and the interval of convergence for a power series. Okay, we've talked about interval of convergence before, so let's say you figure out that the interval of convergence of a particular series is -2 to 2. So that would be my interval of convergence. Now we're also going to talk about what's called your radius of convergence, which we're going to use capital R to denote. And basically your radius is a number. It's how many units you're going in each direction from the middle. So the middle of -2 to 2 is 0, and I'm going 2 units in either direction. So that radius of convergence is 2. If your interval of convergence was 1 to 3, well, the middle of that, or the center, would be 2, and you're going 1 in either direction, so that radius of convergence is 1. So here's the first example. Find the radius of convergence of this series. You're going to start the exact same way that you would start interval of convergence. Either it's a geometric or you have to use the ratio test. This has factorials. It is not a geometric, so I'm going to use the ratio test. So n plus 1 factorial times x to the n plus 1 divided by the original. I can simplify this. N plus 1 factorial over n factorial leaves me with an n plus 1 on the top, and then x to the n is left on the top. So this limit, if I plug in infinity for n, is just infinity because you have infinity times some number x, which we don't know what that is. Now, ratio test says it only converges if this limit is less than 1, but you get infinity, which is never less than 1. So basically, there's no interval of convergence here. So our radius of convergence is 0 because you don't have a center, you're not moving either units either direction. Now, there is one value, if your radius of convergence is ever 0, there is exactly one number that x can be that will make this series converge. So if you look at this series, there is one number you can plug in. If you add up the terms infinitely, it will get you to a sum. And that value in this particular problem is 0. Because if I plug in 0 for x, every single term in your series is 0. So 0 plus 0 infinitely is 0. Okay, let's try the next one. Find the radius of convergence of this series. You can use the ratio test if you want, but I do notice that it is geometric. So I notice that your R value is x minus 2. And I know in a geometric that it only converges if the absolute value of R is less than 1. Now, if you want to solve the inequality, you can. So I get to here. So notice the center of this is really 2, and I'm going 1 unit either direction, so your radius of convergence is really just 1. Now, if all I'm asking you is for the radius of convergence, you do not need to solve the inequality. You can come up with it from here. Because from here I can see, here's your x minus c. This is your center. This value is your radius of convergence. So you can draw the radius of convergence conclusion from this piece right here. Okay, number 3. Radius of convergence. I see that it is not a geometric, so I will have to use the ratio test. So let's set up my ratio test. I'm going to 1 to the n plus 1, x to the n plus 1. Plus 1 factorial, multiply by the reciprocal. Okay, there's my limit. Let's go ahead and simplify. This will drop out because the absolute value of -1 is 1. I can simplify the x to the n. I'm left with an x up there. Also, I'm left with an n plus 1 if I simplify the factorials. If I plug in infinity, you end up with infinity on the bottom, so this limit is 0. Ratio test says it converges if that limit is less than 1. 0 is always less than 1. So basically, this converges everywhere. So your radius of convergence is infinity because you're going infinity to the right, infinity to the left. Okay, last one. find the radius of convergence for this particular series. Okay, again, you could do a geometric or you could do the ratio test. It's up to you. You can do either on this. Let's just do the ratio test here. So if I plug in n plus 1 for wherever n is, this is going to be 2n plus 2 minus 1, so it really becomes 2n plus 1. Same thing with the 5 on the bottom. And I'm going to flip it, multiply by the reciprocal. Oops, sorry. This should be a 5, and this is your x. Okay, I'm going to simplify this a little bit. Okay, the x to the 2n's will drop out. Same with the 5 to the 2n's. But because you have an x to the negative 1 left on the bottom, if you bring it to the top, really you have an x squared on the top. On the bottom, that 5 to the negative 1 will drop down to make it a positive exponent. So you really have a 5 squared on the bottom, which is 25. Okay, notice here that I don't have any n's, so if I take this limit is just x squared over 25. Ratio test that it only converges if it's less than 1. So x squared is less than 25. So my radius of convergence here is just 5.